Hi, I'm Henry from Marine Meteorological Center, and I'm here to guide you in tutorial accessing BMKG-OFS data with Python. With more than 5 years experience of geoscience data processing, I hope I can share some basic technique. To get ready, I hope you've been prepared of basic Python programming. Also knowledge about multidimensional array and time series data processing will be an advantage. If you are not yet ready, please don't worry. After this course, you can check the tutorial about the related topic. It's very popular, so it's not hard to find on internet. Are you ready? Let's get started. BMKG-OFS or BMKG Ocean Forecast System is the system which have been developed by Marine Meteorological Center in order to get information about ocean weather and ocean phenomena by using numerical weather prediction or NWP. We have two datasets that we will share to you in this tutorial. First is INAWFS. INAWFS comes with 10 days forecast and wind and wave parameter. And the second one is INAFLOW, which contains 3 days forecast of sea current, sea temperature, salinity, and water level. We release this dataset twice a day, 0 UTC runtime and 12 UTC runtime. To get in touch to the data, first we will show you the data viewer that we built. First is static one here. We call it a static because it simply is just an image gallery for map in image format. And the other one is it's more advanced plotting because we combine it with JavaScript animation. So here is the data viewer that we've been built. First is OFS static. OFS static is simply just an image gallery for the map that plotted on the back end. So we're using Python to plot this image. So here we have the menu. We can choose which one the model. We have INAWFS and INAFLOWS, and then we have to choose the parameter, and we can change the time zone, and we can also change the parameter. And here is the two last runtime that we run every day. So if we change it to INAFLOWS, it will change to the default is sea current surface here, but you can change into a different parameter here. So for INAFLOW, it has 5 level depth, and it's starting from surface 10 meter until you get 250 meter here. And then you can change the area here, so it will plot into different area. And another feature is you can export an image into animation, and you can also move to the animation version of this web. So let's move on. This website is built if the back end still using Python, but the front end is using JavaScript. So we can see there is an animation here. So in the left menu here we have a parameter selection, and in the bottom here we have to choose a model, which one model, so we can choose INOS or INAFLOWS. And here is the two latest runtime that we have, and you can animate. We also can get the web profile here, and this is the vertical profile. And yeah, that's all. So you have seen the data plotted on the map. Maybe you have question about it, how to create it, what is the origin format of the data. Is it an image? So let's talk about it. The data that you've seen is output from processing of binary data. We call the data as graded binary data format, or some other people call it as scientific array data. This is a lot. There are a lot of format out there, but the most popular format that we found is like HDF4, HDF5, NetCDF, GRIP, and JAR. Every format has the same purpose. It's to contain multiple array, or in this case is scientific array. But not just only an array. This scientific array has a structure. Every dimension of array relates to another array, like coordinate system. This array also has attributes, so they will inform another people that who want to use the data, so other people can understand what it for, like label or name, units, or short description. I will explain to you as simple as possible, like I said, then it's to contain the array, specifically scientific array. So what is scientific array? So here we have 4 by 4 array, and it have two dimension or two axes, vertical and horizontal, x and y. Every cell has a values, and the cell also have an index. So what is index? Imagine like an Excel document. On horizontal side we have a letter, and the vertical line we have a number. So that's what is called as index. But in this index, in this type of data, is always a number. It's an integer starting from 0, increment by 1. So like 0, 1, 2, 3, so on, from the left to the right, from top to the bottom. So I hope you can understand about index. Next, besides of the main array here, what we have here is called as a data array. We have also the coordinate array. So here we have two coordinate array. So if you have question about how many coordinate array that we need to define, the answer is depend. Because we have two-dimensional array, we we just need to coordinate array. If we have three-dimensional array, imagine like a Rubik, so it must be three coordinate array on every dimension, and length of the coordinate array is must same with the length of the dimension of the data array. For example, if we have three-dimensional array with the size 4 by 5 by 6, so for this typical of array we need three coordinate array, and the length of the array sequentially must be 4 by 5 and 6. And here the important thing of the coordinate array, the coordinate array has their own values. So the values, it can be defined as x, y, z, or latitude, longitude, and time. So here is the example of a very simple and small array, only just a 4 by 4. What we seen in the OFS static that you seen before, that we not only have a color match, but we have also the direction there. So it combined from two data. So one is significant warhead, for example, and the another one is direction array. So it shares the coordinate array. So if we combine these two data, it will become like this. So this image is representative of these two data, but it's on a larger scale here. So we have 480 by 800 here. So like I said, the data on the dataset is not only one data array here, but it has multiple data array. So for example here, we have two data array that contain in one dataset. First is significant warhead, and the second one is wind speed. So this data has a three dimension, and it's sharing the same the coordinate array, so it will contain into binary data. So if we have so many data array on one single data set, it will be more larger. So there will come an issue to transfer the data. So here we're talking about the data transfer protocol. On the common data transfer protocol like FTP, the whole data will send to every client. if there is 3 column, for example, so we need to transfer 3 times. It means if the size of the data is 1 GB, so we need to transfer 3 GB data. It will take very long time and wasting the network bandwidth if the client only just a specific area or parameter. So there is come a software, OpenDAP software as solution for the problem with the OpenDAP. It will become possible to download specific area, time, layer, or parameter, and it well integrated with tools or library that we usually use to read graded data. The downside is we can save network bandwidth, times, disk space, and it's easy to use. So I will take you to see what it's opened up like. So we have an opened up server on the maritime.bmkg.go.id/opened up. So please open the URL and let's see. So here is OpenDAP. OpenDAP is simply just a data catalog, and it's also tools for subsetting the data. So the netcdf will be subsetting by using these tools. So our data is mostly all is netcdf. So first we're going to access the ina webs or ina flows. But first I just want to tell you that before access the page, it will asking for user password. So the user password I will put on the description below on the comment section. So please check it out. So first we're going to open the InnoWave folders to access the over the years. So we're going to choose the latest data here. So for InnoWaves, it has 3 different files here. So it's at global, high res, and regular. So the difference is about the resolution, the spatial resolution. So you can check on the latitude and longitude dimension here. So it have a 3 dimension you can know because it tell on this in the section that you can see there are 3 dimension and it's referred to this data. So what we have here, we have longitude, we have latitude, time, and we have significant wave height, and we also have I think it's wavelength, its period, direction, and we have PHS00 is for wind wave, I think. Yeah, wind wave. PHS001 is for swell, and this is also for swell. And PTP is for period, and PDI is for direction. And here we also have wind direction of northing, and we also have wind direction, and we also has maximum wave height here. The direction, okay, direction is here. So that is wind wave data. And let's move on to the inner flows. So for the inner flows, you can back to the root folder and find the folder called fecom. So in the fecom, you just click the directory. So we're going to choose the latest file here. Here we have inner flows files, and here is the parameter, the variable. So inner flow has 4 dimensions. As you can see here, there are 4 dimensions, and it refers to this data. So it has time, the coordinate it has time, depth. So it have 5 level depth, and here we have longitude, latitude, we have u factor and v factor, and T for temperature, S for salinity, zeta for surface level. So that's all I think for the the open app. But wait, I think I just wanted to show you how to download the data by using the this interface. But I'm going to use enough flows because it's more simple, because it just only have 3 dimension. So I just want to demonstrate to download the data. To download data, first you need to click the dimension here. So all the dimension that you need, and you choose the data that or parameter that you want to download, and then you hit the get as netcdf, and it will download the data here. So for downloading data as a data service, you just need to uncheck all this data, and you are copying this URL to your script or Python script, I guess. So next we will learn about the coding with Python. So I think that's all for the OpenApp service. For this session, we will use this tool. This tool is provided by Google and it's free to use. It's called Google Collaboration. So I hope you already have Google account, so it will connect to your Google account. If you already have Google account and you all already logged in, first you need to open the URL. URL is collab.research.google.com, and if you are the first time visiting this website, you will see nice looking welcome page, and there is some tutorial to use it. So feel free to explore the tutorial, but here we already make some script for you for this session, so you can interactively learning from this script. Since it's based on Jupyter, so I will call it as a notebook, okay, not as script. So the nice thing with Jupyter Notebook is you can put the text or the notes to use as explanation, description, comment about what we are working on. Just for example, now I'm using it as a notes for you, so you can understand about the script, and then you're running the scripts until you are really know how it's work, right? Before we jump into the script, I will take you to look around for the menu and the feature that available in these tools. So here on the top of the page, we will find the drop-down menu. It's very intuitive, you can explore it by yourself, but I will just only focus on the important thing here. So we here have a runtime menu. Here we have run menu, but actually I never using run menu because I'm usually run on the play button on the code section. So I will skip this one and move down to interrupt execution. Interrupt execution, this feature is using to stop the execution process. Restart runtime is using to reload runtime. It will clear all the variable but not installed module or local files. Restart and run all actually is just combination of these two functions. And then we have factory reset runtime. It will reset all the variable and also remove all the module and the local files. So be careful to use this function because it can delete your important files. And let's move on to the manage session. So in this menu, you will see the list of active notebook. Since we are using free version, if you are here have active session that idle too long, it will close by itself. So if you want the session still active, you can open it on the browser and open it as active tab. And let's move on to the left menu here. And I just want to focus to the files menu. This is where the local files belong. So remember, the files that you put on this directory is just temporary and it will delete every 12 hours. So don't put the important files here. You need to put it on the Google Drive instead. And to mounting your Google Drive, first you need active Google account and you log in with this account and then hit the drive icon here and follow the instruction. So here I already mounted my drive on drive backslash my drive and I will put everything that important just in this folder. So it's not a pro tip, but based on my experience, I hope it can help. Next, let's move to the resource monitoring. Here, you can get information about RAM and disk, and on the top of it, we have comment and share menu. It's similar with other Google application. And here is the config menu where you can set the preference like using light theme or dark theme. It also has a link for your Collab Pro if you want to upgrade, and another thing that some funds maybe you can do for your project here. So yeah, I think that's all for the Google Colab feature introduction tour, and let's back to the notebook content. So we are already make a notebook for you, and I will share the link on the comment or description, so please check it out. So we are going to learn here a 7 element or 7 things that we need to do. First is number one is the environment setup. In this step, we will install all the software that we need. So in this runtime, I just install Conda as Python package manager and install some module from different channel that we will using in this notebook project. So we did some research to make the environment works on Google Colabs, and you just need to hit the play button to run the script and just wait until the script is finished. So it will show the installation progress, and if it's done, then you are ready to go. After all the software and the module installed, you can check it by running the script just to make sure your module is installed. And here we have import section. Please read the notes and just run the script. After run the import script, all necessary module is ready to use. And now in this statement, you will using XORA to get the data from the OpenDAV server. So I share the user and the password on the comment section below. Please check it out. And I will put the user and the password here. and then we wait until the output comes out. So we wait here. Okay, here we have the output of the data set. But first, I want to explain about terminology of the data set here. The data set is collection of multiple data array, and every data array has three elements. First is coordinate array, and second is main array itself, and then third is attribute. And here is the coordinate array. We need just only define once for many data array. If we are calling data array here, so all the coordinate array and the related data and attribute will attach. And let's back to the output of the script. So here we have three coordinate array: lon for longitude, lat for latitude, and times for times. We can see the attribute by click this document icon, or we can see the data by click this icon. And it also informs us of the data type. Lon and lat, it has a float 64 bits, and time is numpy dataset with 64 bit. Let's talk about type coordinate before we talk about the data variable. The original data type of time coordinate is actually integer or float because X already coded on default, so it will convert into datetime format. But if we deactivate the decoding times, you can see the origin data is in float 64 bit. So I will just run this and see what happened. And yeah, and it's also have units. This information is necessary if you plan to publish your data to public or to merge the multiple data. Next, we move to the data selection. Again, here we made notes. Please read it carefully. Okay, here how we call the data variable level. And here when we want to select by index, and here if you want to select by coordinate values. It can be time coordinate or spatial coordinate like lat or lon. Here is the example that combine that selecting by index but also selecting by coordinate values. And we can see the data by quick plot like this one. It will show as color mesh because the data that we have is in two-dimensional array. And if we just only selecting the data until we have only one dimension, it will plot it as line chart. Here I have example of time series data extracting from data array HS or significant wave height. Next we are going plot like OFS static, the data view that I saw before. For this example, we will plot significant wave height for the slice of the area and select the first index using iCell method. For the color mesh mapping, we need HS data. And for quiver or row, we will show the direction of the HS. We need nothing, northing and easting data, but the data that we have here is direction in angle degree. So first we need to find it with using the statement sin and cos is simply a Pythagoras formula. And let's check the data first. So we are going to check the HS selecting. Then yeah, we are check U data and V data here. So all the data we need is ready. Let's run to the plotting script and see what the result. And yeah, just run, and after that I will explain the script. Okay, so here we have the result of HS color mesh and direction of SS itself. So how it works, let's check the script. So here I select all the coordinate array that I need. The data here is mean we only need as array, or in this case is numpy array. And then I make a mesh grid of the data where the data will belong. Here I create variable for map focus and put all the variable on the base map method. For the base map method, you can open the URL here. I write on the comment. For your information, actually base map is depreciated, but the model is still working. There are alternative of base map. It's called Cartopy. So I recommend you to refer to the Cartopy. But for this tutorial, we're still using base map because it's still working. And as long as Python version is not upgraded into Python 4 maybe later, then it's still okay to use it. You can change the data map statement here as you like and run the script and see the difference. Here is to set up color map and link it to the plotting, and here is direction overlay. I put the variable above so you can change it if you want to change the size or density of a row and see what happened. And here is a label and legend and annotation, and plot show is for showing the map. Next, we have extracting point. So for extracting point, we need to interpolate the data. You can use nearest, but for the best practice, we need to use interpolate. So we need the we can have the exact value for the exact location. Here we are using bilinear interpolation, but on the parameter we just only put linear. So it will perform multilinear interpolation depend on the how many dimension of the data that we select. Here is for the example, we have two-dimension linear interpolation, or it's called as a bilinear interpolation. And here is the example, and here is the result. And next we have a statistical computation. For information about how many methods that it can be performed, please access the link here. For example, here we are using main method. Here we are compute to get main over the time. So the time is axis is 0. Here for more clear, let's see the data array before the main. So it started with time. So it means the time is axis is 0, lat axis is 1, and long axis is 2. And when we plot the main data, this is the result for the direction. You need to convert first to u and v, and then perform mean for over the time, then convert back to degree, and here is the result. Next is how to manage the notebook, especially on Google Colabs. As you know, Google Colabs has limitations, so we need to compromise and save the data to Google Drive to avoid loss of the important data. Here is step of the connecting to Google Drive, but I already connect, so I will skip this step and move to store the data to Google Drive. So here we have 3 examples. First is Pickle, that we have a numpy file and gridded format. First is Pickle. Pickle is not only for scientific array, but for all kind of variable. It can be string, list, dictionary, JSON data, or anything that store on memory. And with Pickle, you can put it on save or to the disk. Next, we have numpy file. Yeah, like the name, it's only for numpy array. You can use it to save numpy array from the memory to this. And last, we have grid format. It's suitable if you want to share to your college or public, because because you can add additional information as attributes, and you can also have multiple variable inside a dataset. So yeah, that's all. I think you can just modify the script and learn about the script itself, because it's very interactive, and I know you are, and you need to read all the reference of the what I put on the notes there. So yeah, thank you for your attention. If you have any question, please just let me know. Okay, thank you.